Hey everybody, Samuel Singer here, the founder and executive director of Wyoming Stargazing. Welcome to Mind Bending Astronomy. In every episode, we'll share with you, a mind-bending fact about astronomy. Now that we've spent the last few episodes introducing what light, electromagnetic radiation is, and how the double slit experiment reveals the quantum world, we're just about ready to really go down the quantum rabbit hole. As we descend, it's important to understand a couple different basics of quantum mechanics. The first is the idea of the Debris wavelength. Basically, this mathematical equation tells us how uncertain the location of some object is based on its wavelength. This equation assumes that all objects have a wavelength, regardless of how big or small they actually are. For our purposes, what you need to understand is that the wavelength of a photon, a particle of light, or an electron, is huge compared to the wavelength of something like a baseball or any other macroscopic object. The bigger the wavelength, the larger the uncertainty. So, while we can very certainly talk about the location of a baseball or a human at any given moment, there's always a large uncertainty about the location of a photon or an electron before we actually measure where it is. The Debris wavelength thus shows us where the limits of the strange and uncertain quantum world gives way to the sometimes more reliable macroscopic world. However, there is always uncertainty. This doesn't mean that quantum effects aren't evident in the macroscopic world. On the contrary, it's precisely because quantum mechanics makes incredibly accurate predictions of what we observe in the macroscopic world that physicists take it seriously. To understand those predictions, we have to tackle another important idea in quantum mechanics called the Planck Constant. This unimaginably small number, discovered almost by mistake in what Max Planck called a moment of desperation when he applied a mathematical trick to solve a problem, ultimately revealed that energy, time, and length cannot be infinitely divided. In fact, they have finite, smallest quantities. And we've already encountered these small quantities in the idea of a photon of light, or a quanta. What they revealed is that they can be used to explain every object in the universe, including you, glows at a very precise wavelength, or color, and why atoms arrange themselves the way they do in every element in the periodic table. To learn about the details here, check out the following links. I'd suggest watching the first two videos under number 1, Quantum Mechanics Basics. Tomorrow, we're going to explore quantum entanglement and the EPR paradox. Until then, be well, and don't forget to look up.